Welcome everyone. In the second tutorial, we'll be learning the factors which affect the magnitude of induced EMF, and we're covering the second learning objective. So to understand the factors affecting the magnitude of induced EMF, we need to go back to the experimental setups which we used in the first tutorial. So if you can recall, induced potential was generated when there was relative movement of the coil or the magnetic field. Okay, so if the relative movement of the coil and the magnetic field is the cause of induced potential difference in any conductor or the coil, it means that if you can increase the relative movement of the coil and the magnetic field, you will be getting more induced potential difference. So when you're moving it rapidly, you're changing the magnetic field rapidly. You know that the change in the magnetic field passing through the conductor is the cause of induced potential difference. This means that when you'll be moving it faster, you will be changing the magnetic field faster, and it will be generating more induced potential difference. So one of the factor is the relative movement of the coil and the magnet. All right. Now, if we use a stronger U-shaped magnet, or if we use a stronger bar magnet, there'll be more magnetic field lines. So if we increase the strength of the magnetic field, we will be able to change the magnetic field more. Okay, so at a time, for instance, if you move the magnet back completely, okay, there'll be zero magnetic field lines passing through. I'm talking about this magnet. And if you move it all the way inwards, okay, let's assume that there are 600 magnetic field lines, okay, they'll be passing through the turns of the coil. So the change is greater with a stronger magnet. So a stronger magnet will be producing more magnetic field lines, and the change will be more, okay, due to the relative movement of the coil and the magnet. So a stronger magnet will be producing more induced EMF. So the second factor is changing the magnitude of the magnetic field. The third factor is the number of turns in the coil. All right, so for that, let's consider the experimental setup in figure 1. In figure 1, we had one loop of wire, okay, and you can also say that we just had one turn of the wire. Okay, in the experimental setup 2, we have 600 turns, and in the figure 1, we had just one turn or one loop. So let's assume if one loop is generating just 2 millivolts, okay, one loop. If there will be 10 loops, they'll be generating 2 millivolts times 10. If there are 100 loops, they'll be generating 100 times as more. So if you increase the number of turns in the coil, you are increasing the magnitude of induced potential difference. So this is the third factor which affects the magnitude of induced potential difference, increasing the number of turns in the coil. So let's summarize. The three factors which affect the magnitude of induced EMF are the relative movement of the coil and the magnet, the magnetic field itself, and the number of turns in the coil. So I hope you understood the learning objective, and we're going to learn about Lenz's law in the third and the last tutorial of the series. I'll see you in the next tutorial. Thank you.